Hello, everybody. So welcome to week 2. Seems a little bit weird with the spring break happening there, but where we left off for week 1, we were just breaking into the navigation system, and then there were these 2 assignments that are still open, not due till tomorrow or the next day for these 2. But that's starting on an introduction of the state pattern. Let's just talk about these assignments, and then we'll dig into this week's content in a couple of moments. So here's just a general lecture on this state pattern, what that is, and things like that. So commonly in coding, there's something called design patterns. And I'll let you just watch that video on your own. There's a few supplemental things for that. And then there's an experiment for setting up a simple state machine and getting it changing and stuff like that. So it's a very simple state machine that gets set up for an example of a lamp just turning on or off, where it explains kind of how that state pattern can work, where we're setting a light to turn on or off. It has 2 separate states. We're just tracking the state of it and responding differently if our current light, if we're in a certain state or not. So today we'll actually set up something similar to this and show you kind of how that state pattern works as supplementary material to this experiment and everything. For this experiment, there is no submission for it. It's got a 0 weight, so you should still run through that, and once you finish, mark that as completed, but you don't have to turn in a screenshot for this one. So I'm going to just open up a Unreal Engine. Once the launcher starts up. Oh boy, it's going to take a little while. Should have had that open earlier. While the launcher is loading or doing whatever it's doing, there we go. Never mind. We'll hop right into the engine here and launch that and let that load up Unreal. Beyond that, this week, we're going to be digging in a lot deeper into the state pattern. So there's a couple more videos showing you a couple of different types of state machines and things like that that people have come up with. Amelia Moore, as well as the Herald state machines. And in this assignment for building better state machines, has a link to one of my actual favorite books, Game Programming Patterns, Design Patterns. In here, it talks all about the state machine. It also has code laid out in a C# style and demonstrates, actually that's a C++ style, but the code, even though you won't be able to directly copy and paste this into Unreal, just lays out like, here's a function named handle input, takes in an input, does an if check or a branch in Unreal, and kind of shows how that logic would work. So don't get thrown off just because it is showing or demonstrated in another language. It does a really great job of breaking down a state machine and how the exit conditions from each state work. When the player presses B, exits standing, but if it was in the jumping state and the player presses B, there's no exit condition for that. So it can't transition if you press B while jumping and stuff like that. So this is just a fantastic book. It goes into a lot more patterns other than just the state pattern. And this entire book is completely free, straight from this website. I do recommend checking out other chapters and bookmarking this at some point and giving it a little bit more reading than just this chapter when you have some time. So speaking of the state machines, let's go back to week 2. There will be a discussion where you basically are going to take a game designer's look at a game you're currently playing or have played in the past, stuff like that, and try and break down what states you think they might have used to make up their different characters or something, along with what exit conditions would happen for that. So it's to try and get you into that mindset of thinking how things could be done or created for a state machine. And then this week wraps up with getting an NPC to work with a state machine. So before we dig into this assignment, we've got Unreal loaded. Let's go ahead and get it starting a new, let's go with blank template. And we'll just give this a name. Let's see, oh, I do have a navigation assignment. Could just load that up. Nah. Let's see, SCD3 underscore basic state machine. And too long, basic state mock thing. And we'll take a look at how to create a basic state machine and see kind of what I'm referring to when I'm talking about state machine, exit transitions, things like that. All right, so we've got a basic Unreal blank project open. I'm going to just go ahead and save my level before I forget to, and we'll save the current as. We'll just call it level 0. And we'll do something similar to that same project that you'll be setting up. I'm going to just throw a cube in here. We'll actually rename this to a lamp, or better yet, let's just create a blueprint for it rather than developing in the scene. Blueprint class, we'll create an actor. We'll call it BP lamp. And the lamp will have some sort of base on it, which we'll just grab a simple cube. And above the cube, we'll add a light. While we're in the viewport, we'll pull that light up, kind of like it's a lamp with a light source up at the top. Sure. Let's go ahead and change this light source color so it's a bit easier to see. That's still just very whitish red. I'm going to offset this so it also hits the front of the box. And we'll also make sure that the intensity is crazy high so it'll really show up in the scene. File save, don't need project settings. If we drop this in the scene, we can very clearly see that light when it is on. So let's go ahead and we have the option to turn this visible or not visible as kind of like an on or off. So we'll go ahead and use that when we're switching light on or off. So we tested that right here, but we need to create a script for it and respond to this. So let's go ahead and first get the input working for it. There's a few different ways to do inputs in Unreal. In the event graph, we can add an event for a specific key. That's great for like debugging things, but the proper way of doing inputs for a game is through the project settings and the input options. So we can set up a certain action to be run when we press a key. Let's set it up properly here. I'll add an action mapping, expand it, set up what key I want to have happen. We'll say interact. And this will be off the keyboard when I press the F key. When I press F key, it'll run that interact event. And when you're modifying inputs, you don't need to save or anything. It should always be writable if you're not working in source control or anything like that. Back in our lamp, we can say what happens when we press that button. So we'll look for that input action, and we have interact as our only action event. When we press it, I want it to basically toggle that light's visibility. So from our point light, there's a built-in function for all actor components or actors themselves to toggle visibility. And that's as simple as that. But we'll add our other stuff in here. If I press F right now, nothing happens. Reason for that, our lamp itself is never receiving any input. And that's because only like the character that you're currently possessing receives input by default. For any other blueprints, you have to actually enable input on them to interact with them. So we'll go from event begin play and enable input. Targeting ourself, we want this BP lamp to start receiving input events, and we have to get a reference to our player controller, saying it which controller to grab inputs from. Player index 0 is just the first player, so by default that'll be the keyboard and whatever first controller you have plugged in. Now with that, when we play and we press F, we see it's toggling light on and off. Fantastic. And that's easy enough for just a simple thing where we just have two individual states where it's either on or off and things like that. But if we wanted to maybe add like a dim state or a flickering state or a party mode state, things like that, we would have to come in here and add like a big old branch constantly changing what we're going to do. And as that gets more complicated, especially with like something like a character where it has 20 different states, doing all that logic here and doing a branch, is it in this state, go to the next one, is it in this state, then react this way, all for every single input, gets really annoying. Not annoying, but complicated spaghetti code, just a whole bunch of branches falling back onto each other. So that is the point of the state machine. Oh, can you hear me again? Yep, give it one moment. Should be back.
It was perfect timing though, because you said it was really annoying and then you lost.
All right. So rather than annoying, sorry about that. Internet's being fun today. But rather than annoying, it just gets overly complex, and each state you would add on or every little thing you'd need to do would be another branch, and all cluttering up this one big if statement and running a lot of code it doesn't need to. That's where the states come in. The states just keep track of what is in the current state, and every update or every input would just do what it needs to do when it's in that specific state. So there's a few different ways we can do this. Well, a whole lot of different ways to implement a state machine, but let's go ahead and take a look at one today. What we'll do is create individual functions for what to do when interact is called when it's in the on state, or what to do when the interact is called when it's in the off state. So let's go ahead and say interact. And let's say this is for when it's in the on state. On interact. And let's add one for off interact. And when it's in the on state, we'll explicitly say when it's told to interact and it is in the off state, we want to just turn that light on. Explicitly grab that light, turn on, or set visibility to true. Make sure that's checked for true value. When it's in the on state, we'll just immediately tell it basically the same thing, but this time we'll be setting visibility to false. All right. So we have these two functions now to call. Our event graph, we need to have a variable to track what state it's currently in. And a bool would work perfectly fine for whether it's for this example where it's just on or off. We'll add some more and show you what that what more states can do. So I'm going to create a brand new type to actually say what states our lamp has. So I'm going to right click and create under blueprints something called an enumeration. An enumeration, or often referred to as enum, is basically a way of mapping words to a certain number. So it's a way to have a list of words that are easily readable in code, all referencing a certain value. So we'll have e underscore lamp states. Open that up, and we'll add just 2 to start with. We'll have lamp on and lamp off. We can add more as time goes on. Save that. And then our lamp needs to hold a variable of that, so because it needs to know what current state it's in. Rename it to current state. And we'll look up that type we just created. This will be of that lamp states type. If we give that a compile, we can default it to one of the different states. The current value is lamp on. All right. That works out fine since we do have the lamp on when we're first starting. So next up, I want to create a mapping of, I want this to happen if it's in the on state. I want this to happen if it's in the off state. So one thing we could do is just branch based off of those states. As I mentioned, we could do a branch. Is it in certain state? Get that current state. If it is equal to the on state, then we do something like that. Otherwise, else it's in the false state. That's just a big complicated way of setting things up. One thing we can do with enums, and very common with enums, you'll do something where it's going to switch. Switch gives us basically that branch section directly in line, whether it's on or off. And we'll review this again, but when it is in the on state, we'll tell it to do the on interact. When it's in the off state, we'll tell it to do the off interact. And that's still kind of following that same concept of branching. We'll take another look in a moment how to clean that up even more. Another thing I want to do inside each one of these, I don't want it just setting the visibility. I want to say if we just turn this off, we set its visibility to false. We'll make sure to update our current state. Our current state. Yes, absolutely, and I'll show that in a moment. Can we have more than 2 states? Certainly. We'll set it to off. I'm just starting out with the 2, getting it working like this, and then we'll see how we can add more after we get the basics of our state machine set up. And when it is off and we turn it on, we'll make sure to update or set our current state to on. So that current state is always tracking which state is current. On off, transform into giant robot. Might be able to do that. Maybe not a giant robot, but something else. All right. So our lamp should be good to go. We have what's going to happen when it's in the on state and we press interact. What happens when we press, or when it's in the off state and we press interact. Just flipping between those two. Press F and we can turn light on or off. All right. Now, if we went to go add a third state, we could add another state to the enum. Let's open up our enum. And we'll say lamp party mode. Save that. And in here, our switch updated with that new enum branch, and we would have to create a transition from one of the on or off states to go to this. So let's say when it is off, it just goes to the on state. When it is in the on state, before going off, let's switch it to party mode. Party mode, rather than turning the light off and switching it to the off state, we'll just change the color of that. Set light color, and we'll choose a random color. Random, oh shoot, random, I'll get a random vector. And then just plug that right into our light color. So party mode should change that color to a random color. When it's in party mode and we press the interact button, rather than just going off, we have to create a function for it. Party interact. Let's go ahead and let's see, do I want to have it do that every single time? Let's make it a little bit more interesting than just changing the color once. Let's have our party mode actually change a bunch of colors. What we'll do is create a timeline. And won't be able to add one in a function, but we can add one into the event graph. And random color. Or let's say this is party color. Shoot. Random color's fine. Sorry, I decided to change this at last second. And was in the on interact that I was doing this. Move that from here over to our timeline. Our timeline, we'll just always update that as if this timeline is playing, it'll just be choosing a random color constantly. You have to add some stuff to our timeline so it'll play. Doesn't really matter what we're doing here. We're just ignoring the actual animated track I'm using as timeline as just a quick timer that I can turn on or off and stuff like that. I'll just call this blank. I will say it is going to loop, and we'll add a couple keys. Doesn't matter where they're at. I just want to have a timeline to start playing something and be able to stop it at some point. So when we are in the interact or on state and we press interact, what we'll have happen is we'll get that timeline, which is called random color instead of like random time. Oh, I can rename it here. party timeline. We'll tell that party timeline to start playing. Ugh, I just right-clicked on that. Play that timeline. And when we are in the party mode and we press it again, we'll have it stop that timeline. Stop. We'll reset the color back to just red. So point light, set color, back to red. All right, and also tell it that it's now in the off state. Whoops, not get, we want set. So not only set the color back to red, but also tell it that it's no longer visible. All right. Oh, whoops, didn't mean to close that, but we have just this timeline, as I mentioned, as a quick way to set up a random color chooser. Whenever it's playing, it'll be swapping those colors. Light party mode, when we do press interact, we need to make sure we are calling the parties interact so it can turn back off. File save. Play. It's in the on state right now. If I press F, should go to the party mode. Sorry, seizure warning, I should have mentioned. But if we press that again, goes back to the off. Once more, turns back on in that original red state, and so on and so on. One thing I want to pull up as we're actually cycling through this, gamer keyboard mode. Yep. We have this currently debugging and simulating for our lamp. So we'll be able to see which one it's taking and what path it's actually executing if we're running this. If I press F, it's currently in the off state, should run that middle one. We see that branch going through the middle. See that currently went to the on interact, so now it's in the party mode. Goes into the party mode, shuts it back off, and we're cycling through the different states every time we press F. So this allows it for each individual state to just focus on, well, where do I need to transition to? What do I need to focus on? It helps encapsulate the individual state code rather than having it all broken down into one big if statement. We are still doing this branch here, so that's a little bit weird. There's an even cleaner way to do this with setting up, changing which functions we want to call at runtime using event dispatchers. So let's clean that up. And let's set up an event dispatcher or a map to hold which function we want to run. Functions, the maps can't hold functions in here. That's right. Let's switch what state rather than holding the current state in this, and just switch which one of these functions we'll have play for when we call interact. Let's create a, whoops, not just a normal function. Let's create an event dispatcher for run interact. And run interact will take in no parameters or anything like that. All right. And the event graph, we'll just have it call the run interact dispatcher. Right now, nothing's bound to this, so nothing will be responding to it. But what we can set up is anytime we enable input, let's set up our different interact states to switch which function it's calling. So by default, I'd want it to run the on state since our current state is on. So what we'll do is bind to this, we have to select which event we want to have run when we call run interact. We'll have it run from the beginning of play, the on interact event. Now we can't just add on interact like this. It's requesting specifically a delegate. You can change any function you have into a delegate by actually just selecting its functions. It says even select component to see available events. We click that, pull off. There's add event. We can add a custom event. We can create an event from the dispatcher or from a function. Oh, that didn't pop up very well. What did the create event? And normally it has a drop down to select a specific, I forgot to compile. I added the event dispatcher, but I didn't compile. Create event has a drop down to select what function you want to call. Always remember to hit that compile and save. Right now it's just complaining because I haven't selected one. But begin play starts off in the on interact. And then inside the individual functions, as we're changing to the on state, let's go ahead and make sure that, or let's do the off first. Off, on. So when we do run the on, it switches to the party mode. We'll tell it to play that party interact instead. Grab our dispatcher. We'll unbind all from it, clear out anything that's currently bound. And then we'll bind which event. We'll be creating an event. And that event will be, this is switching to party mode. So we'll have it bind the party interact. And last one we have is the off. For off. Not the last one. I haven't done party interact either. Unbind all, bind specifically the on state. Create an event. Use drop down. This is going to on. And back in party, we'll be doing that same thing, unbind all. And as you notice, this is doing a lot of the same functionality in each one of these things. We'll clean that up in a moment. And we'll bind. This is switching it to the off, so we'll bind that off interact. File save. All right. So it should be all good. And our basic object is just telling it to bind a single function to run, runs that single function, and keeps our object functionality. If we press F, party mode, off, on, party mode, off, on. And we have just that nice, easy transition, only running the code we need to, all encapsulated inside its own functionality. Now, each one of the states, as it's switching the state, we see it is doing all this very similar code, just switching which event it's calling based on what state it's switching to. So we can clean that up and create a function for when we change state. Change state, we'll take in what state we want to change to. So we'll add a parameter, new state. And this will be of that enum type, which are called elamp states. When we tell it to change a state, we'll have that mapping which function gets called done right here. I'll be a little bit cleaner here. We always had to unbind everything. So it stops running the current state and tells it which state we want to do after. Oops. Bind. And let's also set our current state. So right at the beginning, when we tell it to change state, we'll have it set our current state to that new state, clear out the bound function, and then based on which one we call, when we're changing to the on state, we'll have it create those events and stuff right here for mapping which function gets called for which state. I'm going to copy this a couple more times for the different states. It's turning off, should go to the off state, off interact. Yeah. And when it's in party mode, should go to the party interact. This function, since we're basically cleaning all that up and allowing this to map the individual functions for what state it's currently in, allows us to clean up this whole end part right here where each state was telling it during the transition which state to run. We just need to let it know that it just changed state. So on interact starts that timeline for when it's in the on state. New state would be party mode. Our off interact, clean that up. That's switching to the on interact or on state. We'll call our state, change it to on. And our party was turning it off. We'll just, nope, not that. Want to make sure to call the change state. And that is off. All right. So compile, save. If we play, we should still have, from an end user experience, the same functionality where it switches to, from on to party, from party to off, from off to on, and so on and so on. Main difference is it's now running a lot less code every single time that button is pressed. If we look and like follow what happens, if I add a breakpoint here and just play this, we press F, it'll pause showing what current code is being executed. We're able to step into this. We'll step into this run interact. Well, it's just running the on interact. It didn't need to do any branching whatsoever when it was right there and just running. And now it's doing the transition. So it's doing the change state, mapping that new state since we pressed F. But as the game's running, it's not doing a whole lot of branching every single frame or anything like that. If we had, if we stopped playing and actually changed our party mode, created updates for each one of these individual states. Still not a great way to set them up. There's a better way actually encapsulating the individual states into their own components and just activating that certain component at a time. But this gives us a start of thinking about how the states work, what kind of exit conditions would need to be set up. We have the same exit condition for each state where we're just pressing the F key. and just running the code for our current state. Any questions about anything I went over so far about how we're switching what current code we're running based on what state we're actively in? No questions. All right, let's go ahead and take a 10-minute break, and then when we return, we'll take a look at this assignment, MPC with a state machine, and talk about that a little bit. So we'll be back at 2:03. Okay, so let's take a look at the assignment here coming up. So towards the end of the week, due on the 18th, which is next Sunday, you will have this NPC with a state machine. We'll be taking a deep dive into that a bit more on Wednesday, but we'll take a look and so you can get a head start on it today. So state machine, we'll just link to this Google Doc. And for this assignment, you'll actually be, we'll provide the state machine for you. It's very common in game development that you'll be working with not only your code, but other code that other people are working on at the same time. So for this, you'll be downloading a starter project called State Machine Assets in the assignments repository. Let's go ahead and download that and just kind of explore it a little bit today before Wednesday's lecture. So you'll download that. I'm going to show where that is in Explorer. I'm going to actually grab these this assignment and unzip it somewhere else other than my downloads. So not just working in the downloads folder. I'll extract it here and then move it somewhere locally on my computer. Let's just open up Explorer. And straight in my C drive, I have a folder that I created just named classes. This is SCD3 class. I'll move that over from our downloads. Done with the downloads folder, and we'll open this project up and explore it a little bit. Let Unreal load up. And I still have this project open. Let me save everything here and close out so it clears up some resources for this project that's loading. It is loading. Taking a while because it's using the old engine version. And it's got compile shaders since I haven't compiled them for this engine version for a while. All right. So here we are given a starter assignment for this. We're in the level experiment to experiment around. We just press play by default. We'll see the characters are navigating. They're changing color based on which state they're in. So some of the states have already been provided for you, such as a patrol and idle. One of your tasks will be to explore this state machine and kind of take a look at how things are set up to understand it a little bit. Don't take too much time exploring how things are set up, because in the next assignment, things will have changed for the state machine to make it a little bit cleaner and simulate somebody actually actively working on other code while you're working as well. But the general gist of it, we have these agents that are set up similar to our previous agent, but using a state machine rather than just always going around. So there's some basic things in here where we have next destination, a way to change the color. On begin play, all it's doing is setting an initial state. That's that patrol state. We see for components, it actually has a state machine component as well as the individual states. We have the nav points and nav index, just like we had for the previous assignment, to hold what patrol route it's going to go. All right. So while it's in here, when it does the overlap, changes to the idle state. So that's how it's actually pausing. If we look at this, when they hit the nav point, they'll actually pause for a moment, then switch back to the other state. So exploring these individual states, as a shortcut, you can actually right click on the component and click edit to open that state up. Whoa, that zoomed in a lot. We see all it's doing when it enters the patrol state, calls override to change the color, and tells it to start moving to its next destination, essentially. All right, patrol is pretty straightforward. Let's see what the idle state does. We check out that one. It's got a little bit more functionality to it. First thing it does when it goes to idle, tells our character to stop moving, changes to a darker green, and then sets up a quick timer. So we're asking the game how much time is currently passed. We'll store that in a float. Then on essentially tick, it's going to run this main behavior essentially. So every frame, it's going to get the current time, subtract what time we started at, and see if that's 2 seconds have passed. If so, that's when we switch back to patrol. That's how we're creating our subtle timer. So we could have done this with the delay, but we wanted to show you a non-Unreal specific way of creating a simple timer and having something delayed out for a certain amount of time. All right. So if that's all set up for you, the actual assignment portion will be showing you how to add a new state called pause, and how to switch to this state based off of key press. And not only that, but it has you dig into the state machine itself, so that as it's changing state, it can store what previous state it was in. And when you tell it to unpause, it just goes back to the previous state. Once again, this one will have a screenshot submission. So make sure you are going through this checklist here and making sure everything is shown. So you'll want to pull up that AI debugging and stuff like that to make sure it's showing the actual path of the one that's navigating, stuff like that. All right, I don't want to dig too much into the assignment itself here, and it is an exploratory assignment, so I don't want to just kind of explore it all and explain it all here. So that is up to you to dig into that. And on Wednesday, we'll talk a little bit more about that and take a look at how to make it a little bit more state-centric, since right now our agent is doing a lot of the work rather than the states themselves. That pretty much wraps it up for today. Are there any questions about any of the content we covered today or what you can expect coming up? Nope. Alrighty, then I'll go ahead and end the recording here, and welcome back from spring break. I hope you're ready to get into more content. Later on, everyone.